In this video, we're going to go through the naming rules for binary ionic compounds. So the rules are pretty straightforward. The cation, which is our positive ion, is always written first, followed by the negative anion. The name of the cation never changes. And for the anion, we're going to drop the ending and add IDE. So let's look at an example. So Na is sodium, and then we have Cl, which is chlorine. So when we take these two and we combine them, we get sodium chlorine. However, according to our third rule here, we want to drop that ending and we're going to replace it with IDE. So instead of chlorine, it will be chloride, sodium chloride. So we're going to keep our cation the same, and then we'll change the ending to be sodium chloride. All right, let's look at another example. It says write the formula and the name for the following ionic compound. So K on the periodic table is potassium. S on the periodic table is sulfur. So what we would do first is we want to make sure that we're writing the cation first. So potassium. And instead of sulfur, it will be sulfide. When we go to write our formula out, notice we have a charge here of +1. We have a charge here of -2. When we have ionic compounds, they're going to have a neutral charge rather. So we want these to cancel out. So if I have one positive and two negatives, I'm going to need two of these to cancel out the two negative charges here. So this will be written as K2S. So two potassiums will give us a charge of +2, plus one sulfur gives us a charge of -2. Those will balance out and we'll have a net charge of 0. Here's our next example. Write the formula and the name for the following ionic compound. So Ca is calcium. And then our F is fluorine. So when I write this out, the cation is always the same, calcium, and instead of fluorine, it will be fluoride. So we're just changing that ending here. And just like with the previous example, we have a charge of +2, we have a charge of -1, so we're going to need two fluorines to cancel out with the +2 charge. So it'll be CaF2. Let's do another example. Write the formula and the name for the following ionic compound. So Mg is magnesium. O is oxygen. Now oxygen's kind of a goofy one when we go to change the ending, as you'll see. So first let's write out our cation, magnesium. And instead of it being, oh boy, how would you even pronounce that? Oxide? That sounds awful. So oxygen's kind of a goofy one. When we change the ending, instead of it being oxide or something like that, it's going to be oxide. So we drop the whole YGEN and replace that with IDE. So magnesium oxide. When we go to write out our formula, we have a charge of +2, -2, so it'll just be MgO. All right, we have two more examples here. All right, in this example, it says write the formula and the name for the following ionic compound. So Rb is rubidium. N is nitrogen. So first goes the cation, rubidium. All right, now nitrogen is very similar to oxygen. Nitrogen is one of those goofy ones that you need to remember the way that it's rewritten. So it's not going to be like nitroide. It's actually going to be nitride. So we drop the whole TROGEN. So just nitride. So we have a charge of +1, -3. So we're going to need 3 rubidiums. So Rb3N. So 3 rubidiums, each with a +1, will cancel out the -3 on the nitrogen. All right, we have one last example here. Write the formula for the following ionic compound. So Ba is barium. P is phosphorus. So cation goes first, so barium. Phosphorus is another that has a goofy rename here. So rather than it being like phosphoride, it's just going to be phosphide. Okay, so this is going to be an interesting one because we have a +2 charge and then we have a -3 charge. So I can't just simply multiply one of them to have them cancel out. We're going to need a least common multiple here. So we have 2 and 3. So what I want to do is I want to list out the factors of each. So we've got, let's see, 2, 4, 6, 8. And then we have 3, 6, 9, 12. So I want to find the first number that, the lowest common multiple of each of these. So it looks like 6 is the first number that both have in common. So 2 times 3 gives us 6, and 3 times 2 gives us 6. So I'm going to have 3 bariums and 2 phosphoruses to cancel these out. So 3 times 2 is going to give us a charge of +6, and then we had -3 times 2, and that's going to give us a charge of -6. So that's how these are canceling out. So if you're not sure, go ahead and write yourself out a table of the multiples, and that's a good way to find the least common multiple and to find the each one. All right, and those are the 5 examples that we went through. Those are how to name binary ionic compounds.